Sometimes the universe, it just puts on a show. Well, it makes science fiction look a bit ordinary.
Right, isn't it just...
Imagine this. A star way out there, 12,000 light years away. And it's not just like orbiting a planet.
Mm-hmm.
It seems to be actually eating it.
Yeah.
Like a slow-motion cosmic meal.
Yeah, a really bizarre engulfment. That's absolutely what we're diving into today.
Okay, so where did this story start?
Well, it all kicked off with a flicker, really. Back in 2020, there was this sudden brightening.
Right.
It was picked up by the Zwicky Transient Facility, ZTF.
Ah, ZTF.
Yeah.
The automated sky scanner.
Exactly. Think of it as this tireless robotic eye. It just scans constantly for anything that suddenly changes brightness in visible and infrared light.
And it caught this flare-up.
It did, and its vigilance really flagged this as something unusual.
And this wasn't just a quick flash.
No, that was part of the mystery. This bright emission stuck around for about 6 months.
6 months, okay.
Yeah. So initially, the label they put on it was a subluminous red nova.
Subluminous, meaning dimmer than usual.
Right. Basically a stellar explosion, but less powerful than your standard nova or supernova. And critically, it was quiet in X-rays and gamma rays.
So the really high-energy stuff wasn't there, which ruled out some of the more dramatic usual suspects for stellar explosions.
Precisely. It immediately made things puzzling.
So what was the first guess, if not a standard nova?
Well, the early thinking, sort of piecing together the data they had at the time, it pointed toward the scenario we have theorized about.
Which is?
A sun-like star getting old, entering its red giant phase, puffing up.
And swallowing a planet that got too close.
Exactly. Engulfing a nearby gas giant. Now, we thought we might have seen hints of this before, maybe twice. But this one looked like it could give us the best data yet, seeing it happen in, well, near real time.
It's the classic story, isn't it? The star reaching the end of its life and taking its planetary children with it.
A familiar cosmic narrative, yes.
But then, there was a twist. You mentioned new observations.
Ah, yes. Enter the James Webb Space Telescope, JWST.
The game changer.
Absolutely. It's just incredible how looking with a different, more powerful eye, especially in the infrared, can completely, flip the script.
So Webb looked at this event.
It did. And those follow-up observations, well, they changed everything. The initial interpretation, while logical with the early data, wasn't quite right.
How so? What did Webb see differently?
Webb's infrared capabilities let us see the star itself much more clearly. And it revealed, well, it wasn't a red giant at all, not even close.
Not a red giant, seriously.
Not at all. The star at the center of all this drama turned out to be a K-type star, an orange dwarf.
An orange dwarf, okay, remind me, those are...
Smaller than our sun, dimmer, cooler. And here's the kicker. They live for an incredibly long time.
How long are we talking?
Potentially up to 70 billion years. Their lifespan is just immense.
70 billion. Compared to our sun, which has, what, another 5 billion before it goes red giant?
Roughly, yes. Our sun's expected red giant phase is maybe 9 to 10 billion years into its total life. So this K-type star, it's practically a youngster.
Wow. Okay, so that completely dismantles the old star expanding theory.
Completely. A K-type star, maybe 70% the sun's mass, it sips its hydrogen fuel so slowly. No way was it expanding due to old age.
But wait, you said the evidence still points to a planet being swallowed.
Yes. And that's the crucial, fascinating part. Despite the star not being a red giant, the signs of a planetary engulfment are pretty strong.
Oh, how does a young, stable star just gulp down a planet? That's the new mystery.
That is the question. And it leads to a different, perhaps even more interesting explanation.
Okay, I'm intrigued. If it wasn't the star expanding, what was it?
The alternative, the leading explanation now, involves the planet itself, specifically a hot Jupiter.
Ah, hot Jupiters. We've talked about those.
Yeah.
Massive gas giants orbiting incredibly close to their stars.
Exactly. Sometimes so close they have these huge evaporating tails like comets because the star's heat is just stripping their atmospheres away.
Right. Super close orbits.
So the revised idea is that this planet was a hot Jupiter, and over a long time, maybe millions of years, its orbit decayed. It spiraled inwards.
How does that happen with a young star?
Well, interactions with the star's outer layers, even if it's not hugely expanded like a red giant, there's still some atmosphere, some material out there. Gravitational interactions, tidal forces, maybe some sort of friction or drag.
Like skimming the star's upper atmosphere.
Sort of, yeah. A very gradual process. This subtle friction acts like a brake, causing the planet to lose orbital energy bit by bit.
And it spirals closer.
And closer.
Until impact. It eventually gets absorbed by the star.
And that's the key part here, right? We've seen hot Jupiters, we've seen them losing atmosphere, but we've never actually seen the final act, the actual moment of engulfment.
That's what makes this event so groundbreaking. We've observed various stages, the tight orbits, the atmospheric stripping, like you said.
Yeah.
But catching one in flagrante delicto, basically being consumed, that was a first. Okay, so the new scenario. Hot Jupiter spirals and over millions of years hits the young K-type star.
And bang. Well, maybe more of a prolonged surge. The impact even of a planet would release a lot of energy.
Causing the star to brighten temporarily.
Exactly. A temporary increase in the star's brightness, maybe lasting about 6 months.
Fitting the original 2020 observation.
Perfectly. It matches the duration ZTF saw.
So what else did Webb find? Any, debris? Evidence of the collision itself?
Oh, yes. That's where Webb's near-infrared vision really shone. It found clear signs of the aftermath.
Like what?
2 main things. First, a relatively warm dust ring around the star, about 720 Kelvin.
Okay, 720 Kelvin. That's pretty hot, like oven hot. A ring of hot dust.
Yeah, warm enough to radiate strongly in the infrared that Webb is sensitive to, circling the star.
And the second thing?
And then further out, enveloping that was a much colder cloud of dust, around 300 Kelvin.
300 Kelvin.
Yeah.
That's closer to room temperature, maybe a bit warmer. You said a cloud.
A colder and significantly more massive cloud. They called it a poof-top cloud, which is a fun image.
But poof-top cloud. Okay.
Okay.
So a hot inner ring and a colder, bigger outer cloud. What does that tell us?
Well, the interpretation is pretty compelling. The warmer ring is likely an accretion disk.
Like the disks that form planets around young stars.
Similar idea, yeah. Formed from the material of the planet and maybe some stellar stuff scraped off during the final collision. It's the immediate debris settling into orbit.
And the colder poof-top cloud.
That's likely material that was ejected more violently during the event. Thrown further out, expanding and cooling down. Like a cosmic shrapnel, almost.
So we're literally seeing the pieces left over from this planetary smash-up.
It really looked that way. The observations paint a picture of that final impact and its messy consequences.
Were there other clues? Gases, maybe?
Yes, absolutely. Webb also detected specific molecules in the hot gas near the star.
What kind?
Carbon monoxide, CO, and also phosphine.
Carbon monoxide. Isn't that usually associated with, young stars?
Right.
Protoplanetary disks, where planets are forming.
Exactly. That's what's so unexpected and interesting. Finding CO here after a destructive event is really quite surprising.
What could that mean?
Well, it hints that maybe even in the aftermath of destruction, there could be potential for new beginnings. The ejected material, rich in molecules like CO, might eventually cool and coalesce.
So destruction leading to regeneration almost.
It's a fascinating possibility, a cycle of destruction, and maybe, just maybe, some form of rebirth, even if it's just forming new complex molecules or dust structures.
And the phosphine? Any significance there?
Phosphine is interesting too, though maybe less well understood in this context. It's sometimes linked to processes in gas giant atmospheres, so its presence might be another chemical fingerprint of the engulfed planet.
Okay, and going back to the colder gas cloud, where did that material come from? Was it all planet or?
Likely a mix, but probably a good chunk of it was stellar material.
From the star itself.
As the planet spiraled in, especially in those final stages, its gravity would have interacted strongly with the star's outer layers, pulling some material outwards. This stellar gas gets ejected, expands, and cools down.
So the planet's death throes actually pulled material off the star, creating part of the debris cloud.
That seems to be the most plausible explanation for that colder, massive component.
Right, and what happens to all that ejected stuff? Does it just drift away?
Some might, but it's quite likely that a lot of that ejected gas and dust will eventually fall back onto the star due to gravity.
Which could, I suppose, change the star's composition slightly over time.
Potentially, yes. It adds another layer to how stars and their systems evolve. It's a dynamic process, even years after the main event.
So, just to kind of wrap this part up, this whole discovery is huge because it's the first time we've definitively seen a planet get swallowed by a star that wasn't in its old age red giant phase.
Exactly. It's the first confirmed real-time observation of this specific scenario, the demise of a hot Jupiter via orbital decay into a relatively young, stable star.
It really gives us a concrete example of one potential fate for these incredibly common hot Jupiter planets we see everywhere else.
It does. It shows that planetary engulfment isn't just an end-of-life thing for stars. It can happen earlier, too.
Which brings up a really big question, one that maybe for everyone listening to think about. Could something like this kind of planet-eating event, have happened here, in our own solar system, way back when?
That is a profound question, isn't it, when you look at our solar system compared to many others?
I seem to be missing something, right?
We do. One of the big puzzles in planetary science is why our solar system seems to lack close-in planets. We don't have hot Jupiters, we don't even have mini Neptunes or super-Earths orbiting close to the sun.
But those types of planets are everywhere else. Exoplanet surveys find them all the time, so why not here?
It's a genuine mystery. They seem to be incredibly common around other stars, which makes their absence here quite conspicuous.
So, could an early engulfment event be the answer? Could our young sun have swallowed any planets that tried to form or migrate too close?
It's certainly a plausible hypothesis now, especially seeing this event around the K-type star. If a hot Jupiter, or maybe a super-Earth, formed or migrated inwards early in our solar system's history,
it might have suffered the same fate, spiraled in and got consumed.
It's a distinct possibility. It could neatly explain why we don't see those types of planets in our inner solar system today. They might have been early victims.
And if that happened, would there be any traces left? We saw the dust rings and clouds around that other star.
That's the tricky part. Over the 4.5 billion years since our solar system formed.
Yeah, any dust rings would be long gone, presumably.
Most likely, yes. They would have either dissipated, fallen into the sun, or maybe been incorporated into other forming bodies, like the terrestrial planets or the asteroid belt. Finding direct evidence now would be extremely difficult, if not impossible.
So it remains a tantalizing possibility, a potential hidden chapter in our solar system's history.
Exactly. A past engulfment event could be a key piece of our own origin story that we just can't directly see anymore.
Wow. So ultimately, this discovery isn't just about one wheeled star 12,000 light years away.
Not at all. It opens up whole new avenues for understanding how planetary systems form, how they evolve, and, well, how they can sometimes come apart.
It suggests planet engulfment might be a more common and maybe more varied process than we thought.
Definitely. It shapes the final architecture of planetary systems across the galaxy in ways we're only just beginning to appreciate.
So next time you're looking up at the stars, maybe spare a thought for the unseen dramas playing out. Stars eating planets.
And the possibility that our own sun might have done the same billions of years ago.
It really makes you think. Keep looking up, keep wondering, and we'll catch you next time for another deep dive.